When people hear armored vehicle, they usually picture a tank. Assuming every armored machine is a tank is like assuming every tool is a hammer. The word armored simply means the vehicle is built with protection in mind. And because threats come in many forms, that protection takes radically different shapes. Modern militaries do not rely on one universal vehicle. Instead, they deploy an entire ecosystem of specialized machines, each engineered to solve a unique operational problem. If the problem is direct frontline combat, the solution is the main battle tank. This platform balances thick plating, wide tracks, and intense firepower. But tanks are poorly suited for moving squads of infantry through a war zone. That is the problem the Armored Personnel Carrier, or APC, was built to solve. It acts as an armored bus, prioritizing protected interior space. Sometimes infantry need to move into dangerous areas, where an APC's light weapons are insufficient. The infantry fighting vehicle gives those troops a heavily armed escort that carries them inside and stays to support them with a dedicated weapon turret. This split-screen cutaway shows how the two differ. On one side, the APC maximizes passenger room. On the other, the IFV trades internal space for a larger turret, heavier ammunition stores, and advanced sensors. These three machines dominate direct fire engagements. However, their massive weight and wide tracks make them slow on long patrols and vulnerable to hidden environmental threats. To cover massive distances quickly, the armored car sacrifices heavy steel plates for wheeled agility. These vehicles can drive hundreds of miles on standard roads to secure borders or scout ahead. A fast vehicle is still vulnerable to buried explosives. The Mine-Resistant Ambush Protected Vehicle, or MRAP, was engineered specifically as a survival capsule to counter roadside blasts. This diagram illustrates how that defense works. Instead of trying to absorb an underbelly explosion, the sharp V-shaped hull physically deflects the blast energy outward, keeping the elevated crew cabin intact. Information is just as critical as physical survival. The armored reconnaissance vehicle operates as the eyes of the force. By shedding heavy armor, it gains the speed needed to scout ahead and raise advanced sensor masts to spot threats early. Sometimes the primary obstacle is distance. The airborne armored vehicle solves this by keeping its profile compact and lightweight. This allows it to fit within the strict weight limits of cargo aircraft for rapid deployment. Water presents an entirely different physics problem. An amphibious armored vehicle uses a large, sealed, boat-like hull to displace water, balancing steel protection with enough buoyancy to stay afloat. All of these designs prove that armor requires compromise. Prioritizing high water buoyancy, strict flight cargo weight, or downward blast deflection means abandoning the thick protection of a traditional battle tank. Heavy combat units burn immense amounts of fuel and require precise coordination. Without dedicated support, a tank column quickly becomes a collection of stranded steel. The armored command vehicle functions as the mobile brain of the operation. It replaces heavy weaponry with workspace, computers, and secure communications, keeping unit leaders protected while they direct the battle. When a tank breaks down or gets stuck, the armored recovery vehicle moves in. Equipped with massive winches and structural cranes, these heavy-duty rescue machines repair or tow disabled hardware back to safety. The battlefield itself is often an obstacle. Armored engineering vehicles use their massive power to physically reshape the terrain. They clear debris, fill trenches, and push through blockades to open paths for the rest of the force. Ground forces are highly vulnerable from above. The armored air defense vehicle travels with the convoy to provide a mobile shield, using specialized radar and missile launchers to track and eliminate drones and incoming munitions. Finally, someone has to deliver supplies. Armored logistics vehicles wrap standard cargo trucks in protective plating, ensuring that fuel and ammunition make it safely through hostile territory. These logistical, engineering, and command platforms are the muscle behind the brawn. Without them, the frontline forces would collapse under their own weight in a matter of days. The concept of protective mobility extends beyond international conflicts. Internal security armored vehicles are adapted for domestic law enforcement, engineered to handle high-risk arrests and unstable crowd control environments. The newest evolutionary step in protection is completely removing the human crew from the danger zone. Unmanned armored vehicles take on the highest risk jobs, like explosive hazard handling via remote control. Advances in AI and sensors are detaching the armored hull from the human crew. Future platforms operate as a distributed network, managing high-risk environments while the operators remain miles from the danger zone. Everything branches out from the core concept of protection into specialized tools for combat, terrain navigation, and logistics. Every unusual feature you see, like a V-shaped hull, antenna mast, or heavy recovery crane, is an engineered response to a specific threat. Armor is never random. Once you understand the problem a machine was built to solve, you can read its exact purpose simply by looking at its shape.